I started with Boreas when I was a postdoc with Andy Brack at UBC. In the second year, I found a job at Canada Center for Remote Sensing in Ottawa. My new boss, Joseph Silla, at the time, he was one of the executive members of the Boreas, and he gave me a PI job at Remote Sensing Science Group 7. I do not know what's the reason. Maybe at the time I look honest enough at the time. So I took it for granted. I did not know how serious was that big research program. As one example was that in the intensive field campaign, in the morning we need to report out, going out, and coming back to report in. Sometimes I do remember to report that I'm going out to which side, then I forgot to report in. And then there was always this problem, where is RSS7? And Forrest was still teaching about this this summer in Beijing when he met me. And at the time I felt that I did not really contribute much to this great research program except contributing some troubles to it. So following the photons, after these two great talks, following the water and the carbon, and following the photons, it is complicated in a way, but it's also simple too, because there are so many photons, I just need to follow a few of them. So where do photons go in leaves? Now we all know that at least in three ways. The photons first excite the chlorophyll, make it to excited state. And the energy is used in three ways. First, most of it is non-photochemical quenching, the heat dissipation. And the second part is all we're interested is photochemical quenching, and that produces photosynthesis. And the third is chlorophyll fluorescence. We are interested in two, but these 1, 2, 3 are all interrelated, as we have done more research now after Boreas. Only recently we are trying to get 2 from 1 and 3. And let me start with 2 first. During the Boreas time, and I was fortunate enough to have some data like flux measurements at 2 levels, one above. But there are 2 sites that measures the fluxes at the lower level. One is on the Brack side in the Aspen with eddy covariance at lower level. The other is southern study area, old brass spruce with the chamber measurements. So at the time, then we have some data to actually estimate MPP at the hourly time interval. At the time, we have MPP only from tree ring studies and biomass increment. But now we have this hourly measurement, then we can test our model. So these, the black dots are the measurements, and then we have this big leaf model. And imagine that these complicated forests that we approximated with a slab of foliage, like a big leaf, and it seemed to work reasonably well, like going through the whole season in the middle, if you set your parameters correct. And the measurements is just hovering around. I thought my model was good, but measurement just noise. But if you look at it carefully, actually, there are periods, now these drying cycles. It's not actually noise, actually it is actual process. So this is a big leaf model, and at the time then we try out something, we pick up 2 leaf model, separate the canopy into one sunlit leaf, one representative sunlit leaf, one representative shaded leaves. And this is by John Norman. And this is, that was very early model. And then suddenly it worked. It followed this variation quite well. So if you do one-to-one plot, this is measured, and this is modeled with 2 leaf, and with a big leaf, it doesn't seem to change much. And this is still quite noisy. The fluxes are small at the spruce side. And look at the Andes side. It has good 2-level measurements. And you see then this great improvement from 1 to 2 leaves. So what was the reason? If we look at these Farquhar, the Grant Farquhar and Joe Berry's model, and you know that the photosynthesis is controlled by 2 processes, nutrient and temperature, and also radiation. These 2 equations boil down to that the first equation may be more applied to sunny leaves. The second equation is straight to shady leaves. And if you have one big leaf, sunlight is always enough. So limitation all fall into the limitation by nutrient and temperature. And this does not change much, so that's why you do not see the day-to-day variation. But if you separate at least, then radiation, the second equation will come into play. So you'll track the measured fluxes. So at least now we need to follow the photons into 2 leaves instead of 1 big leaf. It seems to be a big leap forward in a way that the 2 leaves are used. And so the second is that there are 2 other photon pathways, and they are related to photosystems. It's to do with interaction between photosystem 1 and 2. And these are the 2 important processes. Actually, remote sensing can help. And the Xanderfield cycle is the part of the non-photochemical quenching to do with the pigment change when the light is too much, is under stress. So it will be the oxidation process that reduces reflectance. And when the light is not too much, and so plants are happy, then you have more light emission naturally. So in here, this is what Garman et al. Did quite early on. And you see the reflectance under stress is lower. So this is quantified by PRI. And later, Tom Hilker and Forrest et al. Did great work to interpret the relationship between light use efficiency and PRI. Actually, they found it's very important to separate sunlit and shady leaves. Again, 2 leaves is very important for understanding the remote sensing signal of the PRI. And under their influence, we also set up measurement systems in 2 towers in Canada. One is aspen, the other is white pine. And this system is almost just a copy of what Thomas Hilker and Nicholas and also Forrest developed. And these are the 2 sites. These are the measurements, the hyperspectral measurements, these multi-angle too, because these systems swirl around 360 degrees and all changing inclination angle. And the measurements, and if you do the plot of PRI against the light use efficiency as derived from the tower, it's all over the place. You still see the signal. And then we try to separate sunlit and shaded leaves, again using the 2-leaf principle inspired by Forrest's work. And we use a PRR instead of this normalized ratio. We just take straight the ratio of it. They are very similar, but that helps us to do the mathematics part of that. Then we separate PRI into sunlit and shaded. And also the flux measurements are also separate into sunlit shaded according to the two-leaf model that we previously developed. And these are the relationship. But the problem is that they differ quite a bit between sites. And these are the 4 sites done by Nick's group. And they kindly provided data for our testing purposes. And at our 2 sites, and then we just normalize and these PRI with NDVI, very much like Joe Berry's showed this morning. So they fall into one nice line, and then we did a lot of calculation and compare with PI-derived light use efficiency for sunlit leaves and for the light use efficiency measured from the tower. It seemed to be quite good relationship. And the reason we are focusing on sunlit leaves is that we want to use sunlit leaf to go all the way to important parameter VC max. And I will talk about this in the second talk. And the second thing that is to do with photo systems will be these sun-induced chlorophyll fluorescence. And I think most of you know this. I will skip this part of the work. I think you might have all seen these great plots by Christian Frankenberg. And he relate I have here. He relate the measured fluorescence after some normalization process from GOSAT to model the GPP using 3 models. They fall nicely into one-to-one line. This is very exciting because now we have a way to actually see the photosynthesis going instantaneously. Even this is true, that's really a great leap forward in our global change research. And so we also got interested, and we actually compare our model, BEPS model, with SHIFT GOSAT, also GOM2. And we did not find as good a relationship as those shown. And whatever we do, we could not get as good as those. And so we decided to look at not the monthly data, but actually individual data. And Joanne Joyner helped us providing the original raw data and with all the angular information and so on. And then we compare these with our model, the global GPP. And we correlate between our model result with the first is, and this is just straight average, like a monthly average, and this correlation. And you see that the correlation are very good in mid-latitudes, but there are a lot of missing data in tropical areas. The data quality is just not good enough. And then we tried to separate sunlit and shaded, again using 2-leaf approach. What we get is that first we get hotspot. We convert through angular correction. We convert these into the direction that we follow in the sun. You all see is sunlit leaves. We convert that through a very rigorous mathematical calculation. And then we take the ratio of sunlit and shaded. Well, this is still not enough data. And then remainder part is shaded leaves, and this is total. Then we do correlation of this total against our total GPP, then minus the original without correction. And here you see the improvement in R square, in R. And mostly is positive, it's red color. very significant. So if you consider it in two-leaf way, then I think we can use the satellite measurements at various angles, varies over time, because of the sun angle change. Even you just look vertically. And so these normalizations seem to have significant improvement. We are still in the process of writing a paper in this one, and this benefited greatly from a lot of discussions with Joe Berry. So I will conclude my first part. I'm not over time, right?
No, you're good.
I'm good, okay. So during and after Boreas, we started throwing the photons in various ways with a lot of sweat, really. We fail a lot of times. But learned a few things. And the first is the mechanistic Farquhar's photosynthesis model requires to follow photon to at least two leaves. So big leaves now, I think those big leaf models are being replaced by two-leaf models. But remember that our light use efficiency model, still popularly used, is even simpler form than the big leaf model. And now there are recent development of separating light use efficiency big leaf model into two leaves too. Quite a few publications has been done. And the second is the interpretation of remotely sensed PI and the shift also requires us to do the same. And we are convinced on that. I think Forrest and others are also working on this too.